Hey everybody! We've already learnt about energy profile diagrams, and you should be able to recognize which one is exothermic and which one's endothermic, but we're going to look at how you actually draw them now. So remember, there's two different types of energy profile diagrams. There's the ones that represent exothermic reactions, and then there's the endothermic reactions. Okay, so remember, exothermic reactions, they're the ones like combustion and lots of other reactions that release heat. So we should remember that. Exothermic reactions, they release heat into their environment. And then, so if you're standing in the environment nearby, you'll be able to feel that heat because the environment is warming up. So that's why if you're standing near flames or a fire, you can feel that heat because you're in the environment that's getting warmer. So the environment heats up. Okay, well, let's look at how we draw an energy profile diagram. So an energy profile diagram is a graph. So we'll start off by drawing our two axes. We only need the positive part of the axes though, so we'll draw the positive sides a lot longer. So what the profile diagram is measuring is time along the bottom, because we're watching the reaction as it progresses. And then at the top, on the vertical axis, we're measuring energy, because we're seeing how much energy is in those chemicals, in the reactants compared to in the products. So for exothermic reactions, they start off with really energetic chemicals at the start, like fuels, like wood. Everything that can burn really easily has lots of energy in it as a chemical. So we write the reactants near the top here, because they're representing high energy chemicals. And then as the reaction progresses, as soon as those reactants light on fire and they start releasing all their heat, they're losing a whole lot of energy into the environment, and that's why the environment's heating up. So since they've lost a whole lot of energy, that means the products have less energy. So as we get later on, then our products are lower down on the y-axis, and we represent them by just writing the products. Okay. You might see also people sometimes write heat being given off with an arrow, or energy. It's a good way of just representing what's happening. It's not really part of the graph though. And then the final thing is, we can see that because the products have less energy, what scientists have discovered is that that means their bonds are stronger. So the final thing to remember with exothermic reactions is that the products have stronger bonds than the reactants. And what that means is that it's hard for the products to actually be part of a reaction in the future. And if you think about it, it makes sense. So after a fire, you've got charcoal left over, and it's really hard to actually burn charcoal to make it become anything, because it's much more stable than the wood or the fuel was at the start. Okay, so the next one is endothermic reactions. And we remember that endothermic reactions absorb heat from their surroundings, and energy, in other words. And that means if you're standing nearby in the environment, then you're actually feeling the environment get colder, as all that heat from the surroundings is being drawn into the actual chemical reaction. So that means the environment is getting colder. Okay, well, if we're drawing an energy profile diagram for endothermic reactions, it's really similar, but the reactants and the products are switched around in terms of their energy levels. So we're drawing our axes. We've got time, and we've got energy on the vertical axis. But now, in an endothermic reaction, the reactants are really stable. So they have not much energy inside those chemicals. So we're drawing them low down on the energy axis. But then over time, as the reaction proceeds, then the energy of the reactants increases because they're sucking in all that heat, they're absorbing all the energy from the environment, so that the products have more energy at the end of the reaction. And then we can also draw our lines to show energy is going in during the reaction to make the products. Okay, so that means if the reactants are really stable at the start, that means they have stronger bonds than the products do. So in an endothermic reaction, it's really easy to take those products and go and react them with something else to make another reaction happen. So the reactants actually have stronger bonds. Than the products. Okay, so that's how we draw energy profile diagrams.